Hello, welcome to Chapter 8, homework questions 39 through 44. 39. Factor the quadratic expressions below. If the quadratic is not factorable, explain why or why not. So let's go ahead and start with question A. We have 2x squared plus 3x minus 5. Set up our generic rectangle where we have 2x squared tiles and negative 5 1 tiles. And so we have to split up our x tiles, but to do that, we need to figure out where they go. We know that the product of the diagonals are equivalent or equal, so we get negative 10x squared, and then we also know that we have 3x tiles, so we know we're going to have a total of 3x. And what numbers multiply to give us negative 10x squared, but add to give us 3x? Be 5x and negative 2x. We place those in the generic rectangle and then figure out the side lengths from there. So we know we need a 2x and an x, and then x times 5 would give us 5x, and 2x times negative 1 would give us negative 2x, and then to verify, negative 1 times 5 is negative 5. So we know that the product will be 2x plus 5 and x minus 1. Alright, let's take a look at B. We have x squared minus x minus 6. So x squared and negative 6. The product is negative 6x squared, and we're trying to add to get negative x. So looks like we'll get negative 3x and positive 2x. We place those in the generic rectangle and find the side lengths again. X times x. Negative 3 times x is negative 3x. 2 times x is 2x, and that gives you negative 6x as well. So that will be x minus 3 and x plus 2. C. 3x squared plus 13x plus 4. So 3x squared and positive 4. We need to multiply to get 12x squared and add to get 13x. That would be 12x and x. Place those in the generic rectangle, and once again, figure out the side lengths. We have a 3x and an x. Or no, that won't work. We're going to switch those around. Or no, that was right. My fault. 3x and x. There we go. And be a 1. 3x times 4 would give you 12x, and then 4 and 1 give you 4. So 3x plus 1 and x plus 4. And then the last one, D. We have 2x squared plus 5x plus 7. So 2x squared and 7. So we need to multiply to get 14x squared, but add to get 5x. And 14 would be 1 and 14. That's not going to work. And 2 and 7 would give you 9. So it looks like this one is not factorable, because there's no product of 14 and sum of 5. So, not factorable. Which also means this is a prime quadratic, because the only factors are 1 in itself. And then the other thing I wanted to kind of talk about on this one is, as you guys are doing this, if you ever want to check your answers to make sure they're right, which we do want to at least have an idea that we do have the correct one, remember, if we work the other way, we're just using the distributive property or the generic rectangle to do that. So if you have 2x plus 5 and x minus 1, do you get the quadratic? So you could use the distributive property and say, well, this would be 2x squared minus 2x plus 5x minus 5, and then you can see that it is equivalent. So once again, let's just make sure that even though we're using this process, that we know whether our answer does make sense. Question 40. A sequence starts negative 3, 1, 5, 9. if you wanted to find the 50th term of the sequence, would an explicit equation or recursive equation be more useful? And so for this one, it would be the explicit equation, because that allows us to find the 50th term by using, by just plugging in 50, where recursive we would need the 49th, 48th, and so on. B, write an equation in first term form. So we need to know what the first term is, which is -3. So the first term is -3, but we also need to know what that value is in terms of how is it getting from one number to the next. So it looks like we're adding 4 each time. So that's our common difference, is 4. So we can write it in first term form by saying T of n is equal to 4. Instead of just saying n, though, we got to go n minus 1 because we are using first term form. And then minus 3, which is our starting value is the term 1. Since, once again, we're using first term form, we don't need to go back to term 0. C, what is the 50th term of the sequence? Well, now we can plug it in. T of 50 is equal to 4 times 50 minus 1 minus 3. So 4 times 49 minus 3 would be 193. So the 50th term is 193. And then D, we have a new sequence, and we want to write it in explicit form, once again using the first term. So we know the first term is 3, and then how are we getting from one term to the next? Looks like we go 3, 2 2/3, 2 1/3, and 2. So it looks like we're going down by 1/3 each time. So our common difference is -1/3. So T of n is equal to -1/3 n minus 1. And then the first term is plus 3. Question 41. As Jalil and Joman practice for the SAT, their scores on the practice test rise. Jalil's current score is 850, and it is rising by 10 points per week. On the other hand, Joman's current score is 570 and is growing by 50 points per week. When will Joman's score catch up with Jalil's? All right, let's see what we can do here. We got 2 different scenarios. All right, so what we don't know is how many weeks. So let's let W equal the number of weeks. And then we have 2 scenarios. We have Jalil's current score is 850 and is rising 10 points per week. So we have 10 points per week plus 850 as the expression. And then Joman's current score is 570 and is growing 50 points per week. And when will Joman's score catch up? So if we set these 2 expressions equal to each other, we will find when their values will be the same, when their scores will be the same. So we subtract 10, that'll give us 40W, subtract 570, and that will give us 280. Divide by 40, and W is equal to 7. So there are 7 weeks before they will have the same scores. And I set it up as an equation. We could have done a system, could have done a table potentially. So there's multiple representations on how you could actually figure this one out. If the SAT test is in 12 weeks, who will score the highest? Well, we can see that Joman's increasing at 50 points per week, and at 7 weeks they're the same. So then at that point it seems like we don't necessarily even have to calculate. We could, but we don't have to calculate based on the growth of Joman's test score. So it appears that Joman will have the higher test score by week 12. Question 42. Mary says that she can find the x-intercept by substituting 0 in for x, while Michelle says that you need to substitute 0 for y. Who, if anyone, is correct and why? So if we're looking for the x-intercept, we're looking for the x value when y is equal to 0, because these are the points that we would be looking for on the x-axis. So if that's the case, then Mary says that she can find the x-intercept by substituting 0 in for x. That wouldn't be correct. We need to substitute 0 in for the y value. So it appears that Michelle is the correct one. And it says to explain, and we kind of just went through why, and that's because the point falls on the, or lies on the x-axis, and that is when y is equal to 0. B, use the correct approach to find the x-intercept of negative 4x plus 5y equals 16. So it says the correct approach. I'm not sure exactly what that means in terms of correct. I think there's many ways to be able to find this, but based on, I guess, what we just talked about, if we are finding the x-intercept, then we can plug 0 in for y, and then solve for x. So this would be negative 4x equals 16 divided by negative 4. And so the x-intercept for this linear equation would be negative 4, 0. Question 43, find three consecutive numbers whose sum is 138 by writing and solving an equation. Now, because it says by writing and solving an equation, we need to be able to figure out how to write the equation. Otherwise, we could just maybe kind of guess and check our way through this one. So we're going to have to write some let statements here. We want x to equal the first number of our three consecutive numbers. So we're looking for three consecutive numbers. And then if x is our first number, then our second number is going to be one more than that. So let x plus 1 equal the second number. And since we're looking for three consecutive, then x plus 2 would be our third number. And so just so we understand, if x was 3, then x plus 1 would be 4, and x plus 2 would be 5. So that would be our three consecutive numbers. So if we know that the sum is 138, we can set up an equation. X plus 1 plus x plus 2, so we're adding the three numbers up, is equal to 138. And now we can solve this by combining our like terms, subtracting 3 to the other side, and then dividing by 3. So x is equal to 45. But we want to find all three numbers, not just the one. So 45, 46, and 47 will add up to a sum of 138. Question 44. Match each rule below with its corresponding graph. Can you do this without making any tables? Explain your selections. And when it says match each rule, that's also talking about an equation, just another way to say that. So we need to match them up. So y is equal to negative x squared minus 2, y is equal to x squared minus 2, and y is equal to negative x squared plus 2. So you can see that the vertex is in different positions on each of these, and they all appear at x equals 0. So we could, find a couple of values on each of these and see if we can match it up without necessarily graphing the whole thing. So for example, on this one, if I plug in 0, I get negative 2. So that means question 1 is out because it starts at 0, 2. So we're either doing B or C here. And so maybe if I find one more point, if I plug in 1. Now remember, it's not the negative that's being squared, it's just the 1. So it would be negative 1 minus 2, which would be negative 3. So at 1, this appears to be at negative 3. This 1 appears to be somewhere between maybe 0 and negative 1. So I would say on A, this would represent graph 2. For B, we have y equals x squared minus 2. So once again, if we get a point here, we can kind of now narrow it down. If I plug in 0, I get -2. Well, the only one that has -2 at this point is at 3. So it appears that B matches up with 3. If you want to find one more point maybe to verify that, you can. If I plug in 1, that would be at -1. And that looks more like where 1 is at, which is -1. So B would be graph 3. And then we could just, maybe guess that we got the first two right, hopefully, and then say C is going to be graph 1. But let's verify at least a little bit before we just assume that. So this is the one where the vertex is at a different place. So if we just plug in 0, 0 squared is 0, -0, it's 0 plus 2 would be 2, and that does appear on graph 1 at 0, 2. So looks like C is graph 1.